you should have been finding the slope, and then you're going to put it into point slope form. And since we've already talked about slope and point slope form quite a bit, what is the slope here? -5/2. Do you guys all agree? We've got people saying no. Let's check then. -9 minus 6 over 4 minus -2. Oops. I need to change that. 4 over -2. So -9 minus 16 is -15. And 4 plus 2 is, if I divide them both by 3, I get -5 over 2. So -5 over 2 is right. All right. Leanne, which point do you like the best? All right, so I'm going to use y minus 6 equals -5 over 2, x plus 2. Let's distribute the -5/2. And when that happens, I get -5/2 x minus 5. And then we add 6 to that, correct? So I get -5/2 x plus 1, and that equals my y. What I did was I found my slope, and I got -15 over 6, and then I simplified it. Okay, so if I need to write a linear equation, it's pretty simple, right? Especially since I understand that it's a function of x up here. Any questions? All right, let's do a new function that you've never seen. Let's do this one. Yeah, you have, yes. All right, I'm actually going to write it slightly different than was there. So you see two of those bracket symbols, x plus 2, and we're going to evaluate it when f of x is equal to -3/2, 1, and -5/2. So f of -3/2 is equal to... Now, I'm going to show you what we're doing here. So right now you're copying down the problem. And then what we're going to do is talk about, well, what that is even. And this is actually just another type of piecewise function. It's actually called a step function. Meaning if I graphed it, it would look like steps. Boom, 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 boom. Okay? There are. That's exactly how your book writes it. Now, what that symbol stands for is the greatest integer less than or equal to the number inside. So right now you're probably saying, what do you mean by the greatest integer less than or equal? Okay, but here's how I do that. So I've got the double brackets. I'm going to plug in the -3/2. So -3/2 plus 2. First thing you have to do is to figure out the -3/2 plus 2. What is that? What'd you say, Whitney? Not -3. Remember, 2 over 1 is actually 4 over 2. So it'd be 4 over 2 minus 3 over 2 is 1/2. So this function... 2 over 1 is actually 4 over 2, right? Because in order to add or subtract fractions, they must have a common denominator. Okay? Or I like to think of it this way. I have 2 pies at my house, and we eat 3/2 of that pie. That means I eat 1.5 of it, right? What do I have left? Half of a pie. Now that you've done the math, we can actually solve this. So what integer comes right before 1/2? What are you thinking? 0. 0. Remember, an integer is like 0, 1, 2, 3, 4, 5, -1, -2, -3. So all this does is always become a whole number. Go ahead and do f of 1 and then f of negative 5 halves also. So I had you do the next two. So I'm going to do f of 1 real quick here. Plug in 1 plus 2. And 1 plus 2 is 3. And since 3 is a whole number, I'm done. I don't have to simplify it any further. So now let's do f of negative 5 halves. So I'm going to plug in negative 5 halves here, plus 2. What is negative 5 halves plus 2? Negative 1 half, right? So I'm going to actually put that in brackets so we can see our work here. Negative 1 half. I'm running out of room, so we're going to pretend the other bracket's there. What number comes right before negative 1 half? There's the answer. Okay? So now that we can evaluate that, we're going to learn how to graph it. Sacco. Yes. It'd be which numbers, if I'm rounding down from negative 1 half, rounding down would be negative 1. All right. Here's our next one we're going to graph. Now, don't panic because these graphs are actually so easy. Now, you can decide if you want to use graph paper or if you just want to use your notes, that's fine too. You don't have to go the whole way to 10. You can probably do one from 5 to 5. Oops. There we go. And I know, again, if you take a look at my lovely picture here, it needs the symbols. That right there and that. Well, let's just do this by, like, picking numbers. What number do you guys always like to start with? 0. All right. If I plug in 0 there, what number do you get? 0, right? So I get 0. I'm going to put a dot right there at 0. Let's plug in some more numbers. How about 0.5? What would that be? You're rounding down, remember? 0. How about 0.75? Now, what about 1? So at 1, I'm at 1. But notice the whole way up to 1, I was at 0, wasn't I? Now, the way I show that I don't include 1 is I put an open circle right there. So I've got a closed circle, and then I've got the open circle right there. Okay. Well, we're going to do some more here so you can see it again. Right here at 1, 0. So I'll show maybe a little bit of a better open circle may help a little bit. That's an open circle. Okay. So right here, this is an open circle. Okay. All right. So let's say I'm at 1. And I put that into the function. It becomes 1. All right. How about 1.25? Still at 1. All right. So I'm just going to draw a line straight across still. How about 0.5? 1. What about 2? It's at 2, right? It jumps. So I can't include 2. It jumps up here. Now what that circle means is I go as close to 2 as I want to, but I can't actually put in the number 2. Like if I put in 1.9999999999999, it rounds it down to 1. So that's why we put an open circle. We draw the line the whole way up to it, but we put an open circle at that number specifically. Nathan? No. No, we did piecewise functions, but those are slightly different. Now, if I keep going, if I do 2 to 3, line straight across, again, 3 over to 4, line straight across. Just so you know, see how it keeps going? It goes on forever. It not only goes on forever that way, it also goes on forever this way. That makes sense? So once you get the first couple of steps, all you do is continue them. Ah, not so bad, right? Well, let's look at my question down here. What do you think would happen if I put a +2 on the inside? Now, when I say +2 on the inside, remember what you've learned back in Algebra 2 about switch the sign of what's inside, keep the sign of what's outside. Anytime a number's on the inside, what does it do to your entire graph? Moves it what? Over 2 is right. Which way 2? Not to the right. Right. That is correct. Should not have said the word right there, Whitney. Okay? If there's a +2 on the inside, it does the opposite, and it moves it to the left 2. So I'd take this point and move it 1, 2 over, and the open circle would go there, and then I could just continue up my steps from there. That's actually when I'm going to add numbers in the front and in front of the X. And we may talk about that eventually, but not today. What's the -1 do? And, oh, I said +2 on the inside. What would a +2 do if it was on the outside? Move it up or down, okay. Which way? Okay, so it would take the original function and it would move all of the points up to. So I'll use this one right here, 1, 2. And I'll put a dot there and move it over. Switch the sign of what's inside, keep the sign of what's outside. Okay? So I know that it says down here, how about -1? We're not going to worry about that. We talked about 2 on both the inside and outside. You guys feel pretty good with those? I'll tell you now, the easiest thing to do is to start with the original function and then move it. That's simpler than actually trying to think of it, where do I put it in my head? So draw the original and then move it. All right. That may change, but we'll talk about that at a later date of when that would change. Yes. Yes. Now, what if it was a minus on the inside? It would move it to the correct. All right. If there's a number in front of the X, that's where it's getting wider or skinnier. Okay? All right. So here's our next function. Anybody know the name of these? I actually said it once. What? Piecewise. Piecewise. So you want to graph pieces at a time. Now you have a couple of different methods, but I finally think I found a method that works the best. So what I do first is I take the number I have right here. I call that my constraint number, and I plug it in to both the top function and the bottom function and figure out what it equals. So take a minute, go ahead and plug in that -4 to the top and to the bottom function. All right, so I'm going to plug those numbers in. If I plug it into the top one, I get -4 comma, what would that be? Well, -4 times -1/2 is 2, minus 6 makes it another -4, right? Okay, now I'm going to plug it into the bottom one. I plugged in -4. What number did I get out? 1. Okay. By the way, since there's only 2 of them, that's half of your work right there. If there were 3, you would have to do it to all of those. Okay? All right. So I'm going to plot a point at -4, comma -4. Now notice right here before I plot that point. See how this conditional has the equal sign? That means I'm going to put a closed dot right there. When I plot -4, comma 1, you see how this one does not have the equal sign? It's going to get an open dot. So I'm going to plot a point at -4, comma -4 that gets a closed dot. And then I'm going to plot a point at -4, comma 1 that gets an open dot. Do you see why one's open, one's closed? Okay. Any questions so far?
Yeah.
Go ahead.
How do you get the constraint over the first? Yeah.
It's going to be my X number right here.
Oh, right.
They have to give me my constraint. Now, Sacco, sometimes my constraints are written like this. So that means I have a piece going from X equals 2 to X equals 4. In that case, I would have had to plug in the number 2 and the number 4. Well, I would plug in the 2 to this one, and I would plug in the 4 to that one also, to the same equation. But when we get to that one, we can look at it, okay? All right. So now that we've gotten the points, let's do the one that's greater than -4. Let's do the one that's on this side, okay, which is X plus 5. What's the slope of that line? 1, okay. And this is the point that we came up for, right? So from that point, I'm just going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1. Oh, look at that. It hits at 5 on the y-axis. Could I have known that from looking at this equation? Yes. So now I'm going to start at my open circle, and I'm going to make a nice line. That's the first equation graphed, but we still have to do the other equation, right? Now the other equation, notice it says less than or equal to -4, meaning it has to be on which side? The left side. Well, what's the slope of its line? -1/2, which means I go down 1 over 2. Uh-oh. If I go down 1 over 2, am I on the correct side? No, so instead, what could I do? Go up 1 and to the right, or to the left 2. I'm going to do that again. Up 1 and to the left 2. One more time. Up 1 and to the left 2. And now make that line. All right, piecewise functions graphed. I'm done. That's it. Notice you have to break it down. If you look at the entire thing at the beginning, that was overwhelming, wasn't it? But I broke it down into making points and then using the slope. That's all I do for a piecewise function. Do I have any questions on piecewise functions? Sacco. Because I used the slope right here. Yes. Well, what I tried to do first, Sacco, was to go down 1 and over 2, but I ended up on the wrong side of the graph. If ever your lines are both on the same side, you're wrong. One of them needs flipped. Okay? All right, last thing we're doing. We're going to write the function that represents the graph. So draw yourself a graph. And there's a point right here. What point did I just make? 7, -3. What type of an equation would this be? Ah. Not cube root. Cube. So this is the parent function. So if they talk about parent functions, that's what they mean. Parent function, there we go. That C is a little hard to read, there we go. Parent function. Now, the parent function's the basic x cubed graph. But this graph has moved, hasn't it? It moved. How far to the right did it move? It moved 7 to the right. Notice since it moved left or right, I put that number in my parentheses. Now since it moved to the right, what sign do I put here? What? A negative sign, a minus sign? Because I used the opposite inside, remember? And it moved down 3. How do I write down 3? Minus 3. And that's the function. That is it. Do I have any questions on that? Switch the sign of what's inside, keep the sign of what's outside. Ah, look how that song just keeps coming back, doesn't it? Any more questions? All right, essential work time. Here's your lovely essential work, 6 problems.